Alright, in this video we're going to do a little bit of a mathematical proof. We're going to do 4 different steps. The first thing we're going to prove is that if you add 2 even numbers together, the result should be even. Then we're going to prove if you add 2 odd numbers together, the result will also be even. Then we're going to prove that if you add an even plus an odd number together, the result is odd. And then we're finally going to prove that if you add an odd number plus an even number, the result will be odd. Alright, so first thing we're going to do is let's take a look at even plus even equals even. It's a very, very simple proof. Alright, so our first proof, we want to prove that an even number plus an even number results in an even number. So we're going to have to take 2 numbers, let's say 2x and 2y, and if we were to theoretically add them together, we should get at the end of it a number that is also even. The reason why I use 2x and 2y is any even number can be written and expressed as 2 times an integer. Alright, so x could be 1, 48, 6,050, 500 trillion, you know, pretty much any number like that. So, what we're going to do is we're going to take a look at these 2 pieces, alright, 2x plus 2y. Alright, and we're going to use a little bit of mathematical operations in here. We're going to pull or extract the 2's from it, so it turns into 2 times x plus y. And we want to say, is that even? Well, we take a look at it. X plus y, it has a property called closure, meaning that if you add 2 numbers within the same number group, they will give you the same result. So x plus y, we could write it as z if we wanted to. We carry down the rest of our items, and we look at it, and we see 2 times z should be an even number, because if we go back to our definition at the top, our definition of even, as given from the even to 2x and even to 2y, is just 2 times any number. So, we've successfully proven that an even number plus an even number is always even. Alright, our second proof, focus a little off, there we go. Our second proof is describing an odd number plus an odd number should give us an even number. So looking back at our definition of even, it's just 2 times a number. So an odd number is 1 extra. So what we could put in is 2x plus 1 plus 2y plus 1. And we're going to check to see if that's even. Alright, so let's start breaking down these 2 numbers. Alright, so I'm just going to rewrite it without parentheses. 2x plus 1 plus 2y plus 1. We want to see if that's even. Alright, let's start combining. Let's take this one and that one, add them together. So 2x plus 2y plus 2. We ask, is that even? Well, let's factor out a 2 from the entire left side of the equation. So it's 2 times x plus y plus 1, and we're asking ourselves, is that even? Well, if we look back at our previous post, we were able to conclude that 2 times z, which is just the product of x and y, is even. So we could take this x and y, those could both match to the letter z again, and then we have the plus 1. Alright. And what we can do on top of that is we can say z and 1 are both in the same number set as well. So we can make it 2 times, I don't know, let's say w. And we can ask ourselves, is that even? Well, looking back at our previous proof, we came to the same conclusion. So yes, we have proven that an odd number plus an odd number will always result in an even number. Okay, our next section, we're going to look at our third piece. An even number plus an odd number should result in an odd number. So let's write it out. This is 2x. An odd number we can express as 2y plus 1. I'll throw parentheses around them so we can better identify where they're coming from. Alright, and we're going to ask ourselves, is that odd? Alright, so we can drop the parentheses through order of operations. So 2x plus 2y plus 1 equals odd. We're still asking ourselves that question. Okay. We're going to factor out a 2 from the 2x plus 2y. Alright, and that leaves us with 2 times x plus y. Then we add 1. We're going to ask if that is still an odd number. Well, as we've done before, we've turned the x and y into z. Alright, and that is 2 times a number plus 1 equals odd. Yes, it is indeed odd, because that is how we wrote our first odd expression. Alright, and in the last piece, we're going to just basically reverse the order, but just in terms of, being thorough in terms of our proofs, we will finish it up with a fourth proof. So, now we're looking at proof number 4. An odd number plus an even number equals odd. We're going to notice that the results are going to be very, very similar to the third proof, and that's completely fine. So, we're going to take an odd number, 2x plus 1, plus an even number, 2y. We're going to ask ourselves, is that odd? Alright, we're going to drop the parentheses, so 2x plus 1 plus 2y equals odd. We're still asking ourselves, is that odd? We're going to rearrange the order of our added values because we can do that with addition. So we're going to swap 1 and 2y. So 2x plus 2y plus 1 equals odd. We still ask ourselves. Alright, and then finally, just like before, I'm going to factor out a 2 from the 2x plus 2y. So 2 times x plus y plus 1. We're asking ourselves, is it odd? Alright, and then yes, so because the x plus y can turn back into a z, and we come back to our original point. 2 times a number plus 1 gives us odd. Alright, so just to draw some conclusions from this, we've proven mathematically, beyond reasonable doubt, that whenever you take an even number and add it to an even number, the result is even. Similar process, when you take an odd number plus an odd number, the result is even. When you take an even number and add an odd number, the result is odd. And an odd number plus an even number, the result becomes odd. Alright, so over here, I will leave a link to basically go to a similar set of proofs involving multiplication. Mostly because the properties change just a little bit when we're dealing with multiplying odd and even numbers. Alright, so thanks for watching. If you like these videos, please like, comment, and subscribe.